And welcome, YouTube audience, to the Daily Space Weather Show. And it's been an interesting few days when it comes to space weather. We'll start out today's video talking about stuff besides space weather. What about, uh-oh. It seems that a strangely luminous cloud has formed in the living room. And now I'm spooked. I'm very spooked and frightened. Because, look at that cloud. Like, what's up with that? Is that a chemtrail? Looks like a man-made cloud. We'll have to check the cameras to see if a plane has flown through here overnight, but I don't know what's going on. Somebody call Dane Wigington. Somebody call Dane Wigington. Look at that. Would you be terrified if that was in your living room? I certainly am. I don't know what to do here. Oh my God. It looks like an artificial cloud. Holy crow. It must be very dangerous. What do you think, folks? Let us know in the comments what you think. Are you spooked of clouds? Do you know how weather and planes work? Does it make you spooked of clouds, folks? Yeah. So, is everybody done with your raging consumerism for the Christmas season this year? Are you still doing the raging consumerism, or has that expired this year? Now, I made sure that all my elf duties were out of the way by Thanksgiving. So, just a consumer tip. I'm going to do this every year now, I think, because it's amazing. And here's what I did. By Thanksgiving, all the decorations are up. 99% of the shopping's done. Presents are wrapped. Elf duties complete. That's how you do it. That's how you enjoy the holidays. The Wednesday before Thanksgiving, get done with everything by Wednesday. Not by Black Friday. Not by Christmas Eve. Not by December 10th. No. Get it done by Thanksgiving. Why? Then you can enjoy the holidays, folks. That's what you want. Get your elf duties out of the way, and then any that remain that you haven't completed, it's you doing it at that point, not the elves. So, maybe that'll help you out. I don't know. Maybe it'll hinder you. I don't know. Don't consider this to be advice, folks. I don't have a coaching certification yet, but it's coming. So, yeah, multiple space weather impacts still on the way here. I believe there's one slated to arrive basically at any moment. So let's head to the studio and take a look at some stats. In the meantime, here's that man-made cloud, folks. And, damn, we're very scared here. This appears to be a man-made cloud, and it's freaking us out. So hopefully that'll subside at some point today, and it won't kill us. Maybe we'll do some mass spectroscopy and make sure that cloud isn't dropping scary chems on us, like strontium and barium and aluminum and all kinds of other very frightening chemicals. Oh, I'm spooked. I'm spooked, folks. So just so you know, I'm spooked. So I'm part of the solution, folks, because I'm spooked. And that's what you gotta be. You gotta be spooked. So I'm very frightened right now. Just trying to control my hyperventilation because of that man-made cloud. Oh man. Dude, it's like, who knew that United Airways has it in for us? It's terrifying. I'm spooked, and never the twain shall meet. So let's talk space weather here briefly. We'll talk about Earth weather as well, as it's a little on the cool side here in Eastern PA. This morning, the car thermometer said 9 degrees Fahrenheit. 9 degrees. That's pretty cool, right? That is what you call chill. It's chill. Know what I'm saying? All right, so let's bring up our space weather console so that we can tell you what else is going on, since there may be even more CMEs on the way. We'll cover it. So just bear with me a quick minute here and we'll get into it. In the meantime, please leave a comment, press the share button, and tell your friends and foes about the world's most comprehensive daily space weather videos. We don't really see the content propagating on the internet because I guess there's not enough fear-mongering and too many facts expressed. So, sorry. Although your personal experience really shouldn't be affected by what dummies on the internet are doing. And there are so many of them. So many lazy dummies on the internet who are too lazy to even simply read about a thing before arguing about a thing. I'd say it's adorable if it wasn't so freaking annoying. So let's just do a quick cosmic ray report here, since we haven't talked cosmic rays yet. And we haven't talked cosmic rays on the channel for a while. So let's briefly talk about cosmic rays. So cosmic rays are like a stellar wind that's not coming from the sun. All right, cosmic rays, they can come from deep in the galaxy, other star systems within the Milky Way galaxy, or even from different galaxies, perhaps. They're mainly comprised of hydrogen nuclei, just like the solar wind. So very similar components to the solar wind. It's like cosmic rays are about 92% hydrogen nuclei, except the difference between cosmic rays is they're moving real fast. They're moving so fast, they make it all the way down to the surface, and then they cause a particle shower. And I'm not going to get into the physics of the particle shower because, frankly, it's not really space weather anymore at that point. It's Earth weather. But yeah, those particles are coming from space. We only know one point source for cosmic ray flux, and that's because when cosmic rays are like little tiny magnets that are flying like bullets through the galaxy, the universe. And when they get near a magnetic field, that magnetic field can alter their trajectory. So they can make all kinds of crazy turns. It's very hard to tell where cosmic rays are coming from. We discovered the only known point source back in the early 1980s, late 70s, and it's called it's called Cygnus. What is it called? Cygnus X3 is the only known cosmic ray point source. It's about 32,000 light years away, about 6,000 light years farther away than the galactic core. But that's one of the few, the cosmic ray point sources that we are aware of. And like, it's a major cosmic ray source, okay? A lot of the cosmic rays coming in are from this object directly. And there's basically a clear line of sight all the way from us to X3. There's just enough of a pathway, because Cygnus is a very full part of the galaxy. Cygnus is a major galactic arm, and it's in between our solar system and the core of the galaxy. So anyway, so that's cosmic ray flux. As you can see in this bottom graph here, which dates all the way back to 1965 from Oulu, Finland, we haven't seen these levels of cosmic ray flux for over 20 years. Back in 2004 was the last time we saw cosmic ray flux as low as it is. So anybody telling you that energy from space is increasing or some nonsense like that, it's nonsense. Energy from space is definitely not increasing. In fact, even solar activity is on the downslide. We're on the way down back to solar minimum. Energy from space is definitely not decreasing in any way. Like, I mean, you could say from now until 12 noon, energy from space is increasing because it's going to get sunnier. So yeah, infrared and ultraviolet radiation from space is going up. So that's energy, I guess you could say. But if you just hear somebody on YouTube just say the word energy and they don't tell you what they're talking about, then they're useless. You know, because there's all kinds of energy. Energy is simply the ability to do work. It doesn't, if somebody just says energy, that's a meaningless thing. Like what kind of energy? Like the energy stored in gasoline, the energy stored in plutonium, the energy required to ride your bike, the energy from you know the energy holding an atom. Like it's like, oh my gosh, it's so ridiculous. Anyway, here are the Antarctica neutron monitors, and look at how low the levels are here. We're seeing a 4 Bush minimum almost, right? Anyway, yeah, so that's the point. Cosmic ray flux is at a 20 plus year low. Moving right along to some more space weather stats here. Let's take a look at the closest star first, and we'll separate this tab so we can always put it on screen as I rant about various things. There we go. It's the GOES 16 SUVI, and of course there is still activity, plenty of it going on, and it's pretty out of control, really. I mean, we see plasma waving around here again, and some flaring. So, we did have an X-class flare that we covered yesterday during the live stream, and thanks to everybody who tuned in. Once again, congratulations on realizing that the channel exists. It's only the world's most comprehensive daily space weather content, dating back to 2019, when we founded SmashOmash.com. And let's take a look at some more stats. All right, so University of Reading's Huxt forecast is next. And as you can see, multiple CME impacts on the way. That's coronal mass ejections. Don't conflate them with solar flares, folks. Remember, solar flares are photons in the form of X-rays. Coronal mass ejections are protons, mostly in the form of hydrogen gas. That's ionized hydrogen gas, by the way. It's moving so fast, it ain't got no electron, which makes it very reactive when it does indeed encounter the Earth's magnetosphere. Or chemicals. Yeah, a hydrogen nucleus with no electron really wants an electron. And so it's going to steal it when it meets up with somebody's outer shell, some other atom or molecule's outer shell. So here is our sunspot number, which has come down a little bit here. Sunspot number now down to about 158. 158 sunspots is the current state. And the state of my voice is improving. 10.7 centimeter radial flux has come down as well. We're seeing a decline in solar activity. Radial flux is at about 187 solar flux units. It's 187 on the MF and radial flux. All right. Next, the GOES 19 SUVI, the GOES 19 coronagraph. And it looks like more CMEs are on the way. So we've got one slated to arrive basically at any moment. And then we've got 2 more behind that. And then it looks like we have another one from today. So another CME impact likely to happen early in the day on the 12th. That would be Friday. Early in the day on Friday. So there could be some great opportunities to see the aurora, folks. We hope you get clear skies where you're located, if indeed we see major CME impacts and mid-latitude aurorae. Shout out to our viewers from all around the world. I'm going to repair my tabs here real quick. So we're going to show you 304 angstroms once again, because it's great at showing prominences, active regions, flares. It's a very good all-purpose wavelength. That's the past couple of hours there. Oh, geez, they've increased the amount of time that's shown on the Goes 19 SUVI. Look at that. It's many, many hours. What the heck? It's showing 12 hours now about instead of like 2.5 hours. That would explain why it plays so slowly. But that's convenient because it shows us more action. Look at this CME. There's a CME popping off right there. Wow. All right, so let's take a look at this one, which propagated right around midnight. All right, just a minute here. We're going to bring up stereo A, but I got to refresh my tabs because old tabs take our time, and we don't want that. We know your time is super valuable, folks, because slave labor. It's fun, right? It's fun. Yeah, you're devaluing dollars. You're devaluing dollars and you're declining wages and you're declining everything. It's just great, pardon my sarcasm. All right, so we're going to bring up stereo A next. Stereo A's Core 2 Space Weather Beacon. So yeah, there's definitely another CME, and there's another CME right after it. Look down here, there's another one that pops off right here. You can see another filament. So lots of action. And just a quick reminder, folks, not only do we not conflate coronal mass ejections with solar flares and vice versa, but we look at the data because coronal mass ejections happen with no flare all the time, folks. We see CMEs constantly at solar minimum. So it's, you have to observe the data or you're not going to have any clue what is in it. You have to look, you have to read. Like, I know it's so much to ask. Oh my God, it's so much to ask. You got to read a thing. Oh no. Like, know what you're talking about before arguing about it. So here is our stereo A coronagraph. And like I said, I'm pretty sure we got another 2 more CMEs, which would have the total up to 5 on the way now. 5. Okay, so that one there does not look like it has an earthly directed component, but it may, because Earth would be off like in this direction from stereo A, excuse me. All right, so there's our space weather beacon, and look, right after midnight, we can see a CME propagating there. It's mainly going to the north of Earth, but then there's a second event there that you can see that's more slow, and that definitely has an Earth-directed component. Look right here. Look at this ejecta right here. I'm going to rock it back and press play. All right, check this out. The first CME, mostly missing Earth. The second one, watch out here. Here comes the ejecta. There it is. It's earthly directed. So that is a 4th Earth-directed coronal mass ejection. So that's pretty exciting. By the way, we've got 4 viewers and 4 likes. That's always nice. Thanks to everybody who's pressed like. You are the people who use turn signals when you drive cars. If you're new to the channel, press subscribe, or you may not see the content. Look at this. We got a major CME impact likely right here. So we could have major geomagnetic storms today going into tomorrow. But it looks like NOAA is missing some of these CME impacts. So I don't know. Sometimes they're stealthy. Sometimes people are just asleep at the wheel. You be the judge and let us know in the comments what you think. Or just lurk all day and never freaking leave a comment and just pretend like we don't exist. You're welcome for covering space weather in a rational fashion. Of course, the most important thing, folks, is pressing the share button. And let's move on to the real-time solar wind. Now, right now, the active spacecraft is the ACE. Keep in mind, these things are measuring the solar wind at Lagrangian point 1, which is about 1,000,000 miles away. And at the moment, we ain't got no CME impacts, or if so, it's pretty weak, considering we only have a solar wind density of 5% of a proton per cubic centimeter, only 0.19 protons per cubic centimeter, and only traveling at 360 kilometers per second. So that is not a CME impact of note. Let's just take a look at the other spacecraft here. We'll look at Discover briefly. Since we do have a recent variation right here. You can see there is a variation right there. The plasma temperature, solar wind density, velocity, and the magnetic field all change at once. So let's take a look at the Discover. So there's the Discover, and it's got missing data. So, but showing quite different data there. And let's just put this back to the active spacecraft and move on as we await coronal mass ejections with all the rest of you nice Earthlings. No new energetic particle events, but the likelihood of that is actually rising as we have active sunspots headed to the limb. By the way, don't forget to follow us on the social media junkware platforms. You can find all of our links at the homepage at smashomash.com. Founded in 2019 when we started running this channel as a business. And yeah, smashomash.com. It's where you can find links to the Redbubble shop and links to the Twitter and so forth. Everybody presses that share button and clicks on social media to help get our content onto people's screens. So a number of M-class flares and one X-class flare that we showed yesterday during the stream. Let's pull up the one-day chart here from the X-ray flux. So some multiple long-duration M-class events here and some flaring happening as we make the video once again today. So shout out to El Sol. Here's the current magnetic environment for the heliosphere. Earth is solidly in a South Pole magnetic sector, and no, coronal holes cannot be used to forecast earthquakes. Why can't coronal holes be used to forecast earthquakes? Would anybody like to answer us in the comments? There is a reason. There is a reason why coronal holes cannot be used to forecast earthquakes. Here's why, folks. You can't say, here's a forecast. All the world's fault lines are at risk for a quake because of the sun. That's not a forecast. You got to have a time and a place for a forecast. Where is it? How are you going to do a time and a place? By saying a coronal hole causes earthquakes. Secondly, if you say coronal holes cause earthquakes, you have to have the data that shows it's not just a correlation, but that it's a causation. Do you see how many logical leaps you are away from calling that science? It isn't science. Coronal holes don't cause earthquakes. And if they did, they would strongly correlate, and instead they barely correlate. So, in fact, you could make the argument that coronal holes don't correlate with earthquakes, as we've seen plenty of big earthquakes with no coronal holes and plenty of coronal holes with no big earthquakes. So there's that. Next, our line of sight coronal hole plot. And we've got big time South Pole oriented coronal holes here facing Earth. Look at how weak the North Polar magnetism is right now. It's just down here. It's fixated on the other side of the sun. So as we forecasted early in solar cycle 25, we are seeing the uptick in coronal holes exactly as forecasted. Because the coronal holes have to migrate across the sun. That's the solar polar field migration process happening before your very eyes. South Pole oriented magnetic sector, South Pole oriented coronal holes. They will provide a high speed wind in about 3 days. Next is our ground-based magnetogram. Today we're looking at excuse me. Today we're looking at El Teide. We're only showing today's data because we did a video yesterday. All right, do you see any major changes with these sunspots? I certainly don't. Those magnetic fields are pretty stable. Throughout the day so far today, about 12 hours in to the day of our Lord, December 9th, 2025. Stable. Heading to El Teide for this as well. Here is the latest in red light. That's 677 nanometers. And we hope you have red light therapy. Have you tried it? It's spectacular. I've got one right here. There's a red light bulb. It's so good. Sometimes I like to live life as a French fry. And yeah, red light is a way to do it. It speeds up your ATP engine, folks. So you can find links to some red lights at our Amazon store, amazon.com/shop/Smash-O-Mash. They make great gifts. That light bulb cost about $30. It's about 40 watts. It's got 18 LEDs and 2 different wavelengths. Is it 677 nanometers? I don't know. But this solar imagery is. So I just figured I would share. Anyway, that's what's up with red light. And as you can see, these sunspots are remaining rather stable. However, their likelihood of producing large flares is going up quite a bit as they approach that limb. So that increases the likelihood of large flares and the likelihood of solar energetic particle events. That's the GOES proton flux if you want to monitor it yourself in near real time. Links on SWPSI, the Space Weather Prediction Center, which is a feature of NOAA, the National Oceanic and Atmospheric Administration. Next, El Teide's. Oh, no, Cerro Tololo's slightly newer, so we'll use that instead. We want to give you the most up-to-date data, folks. And of course, to quote Run DMC, on this channel, we always tell the truth and then we never slip no lies in. Run DMC, the wholesome movement, Little House on the Prairie, Run DMC, that's what I'm into, the wholesome movement. All right, now that I got that out of my system, we're going to show yesterday and today, because we may have more filaments lifting off, and it could be a good time to name some filaments. Look here's one lifting off for sure. Right here, whoop, that one goes. One up here goes. It's exciting times for space weather, folks. Exciting times. So there you go. You can see a filament lifting off here. That's a high-speed CME. That one's only going to take 2 days or so to show up. So we may have CMEs interacting with other CMEs here, as well as CMEs interacting with the coronal hole stream, because we have coronal holes over in this area. Still plenty of large filaments facing the Earth, as you can see there in those dark absorption features. That is the hydrogen alpha imagery. And these dark absorption features are more complex molecules blocking the hydrogen alpha. And let's move on. Electron flux remains high as we stay right on electron storm conditions. So we're going to see a bunch of erroneous readings here. We're going to see this drop way down, and it's going to be erroneous. Your GPS will continue performing rather badly. Next, we'll look at the D region of the ionosphere, which is located here about 90 kilometers of altitude. So bear with me while I set that up. Get off my screen, Windows advice. We'll show the anomalygram and the raw frequency. So here's the ionosphere in megahertz. South Atlantic anomaly still on the equatorial Pacific, just west of South American coastline. The African anomaly right on the equator, just west of the African coastline. Very obvious on these data. Keep in mind, these are actual observations using radiography, ionosondes. They're measuring the refraction between their satellite, which knows exactly where it is, and the ground-based station. Quite a bit of action going on in the ionosphere. If you're not familiar with that data, well, this next one might be a little bit more useful for you because it shows anomaly in megahertz from a 30-day median. High frequency anomaly shown in blue, low frequency anomaly shown in red. And yes, the ionosphere is space weather. However, everything below the ionosphere, starting here at the mesosphere, is not space weather. Space weather literally starts right here. And the Schumann resonances bounce inside here in Earth's neutral atmosphere, which is why the Schumann resonances aren't space weather. They take place in Earth's mostly neutral atmosphere. Anyway, look at the insanely high frequency anomalies here and the really ongoing low frequency anomalies happening here, off the coast of western Mexico and so on, just north of the South Atlantic anomaly, which is now in the Central Pacific. Do we have to name the South Atlantic anomaly the South Pacific anomaly? Or the Central Pacific anomaly would be even better? I don't know. You be the judge. But that's where it is, right there. Not down here, and not down here. And here's the African anomaly, also almost right on the equator. Does that mean doomsday? Probably the exact opposite of that. But we want to know what you think, so let us know in the comments. Next, I like this segment. Let's show the sunrise. And then the water vapor map. So here's the sun rising over that lovely blue globe that you earthling noobs call the Earth. There it is. How cool is that? For everybody who says, hey, the Earth is flat, show me a photograph. There's one. Does that look flat to you? Let me guess. It's a flat plane photoshopped onto a spherical 3D transform in Photoshop, right? Yeah, get bent. All right, here is our water vapor map. We'll show this because it'll give those of you who know how weather works insight into things like the jet stream and, you know, what's going on with weather and so on. Yeah, some of our viewers can forecast your own weather, can't you? And we love that. So there you go. There's a water vapor map for the Western world. How's that for some useful info? Dry air dominating the southern part of the U.S. as a massive atmospheric Niagara Falls plus forms over Vancouver. Look at that. It's coming in. Cold air is coming down. Dude, that area is berserk. We're going to show a close-up of that here on the Goes West. Wait till you see this. It's bonkers. Bonkers, I tell you. Crazy amount of moisture here. Look at that. That is some moist air if ever there has been some. Look at the way it's just hanging out there. I mean, these areas are getting plastered with precip. And it's cold. Cold, I tell you. All right, let's take a look at... We'll show the shortwave radiation map and the water vapor map for the U.S. and then a couple more data points. And then this stream is a done. All right, there's shortwave radiation. That'll show you cloud cover. And it's pretty cloudy over the northern part of the U.S. Looks like clear skies over southern Mississippi, southern Alabama, southern Georgia looks clear. But there's a haze over a lot of the nation. And I don't just mean like a haze of... I don't just mean a haze of clouds. I mean a haze of confusion and, frankly, insanity. So here's the U.S. water vapor map. And, you know, like we just said, the story is that atmospheric river making a 90-degree right turn at Vancouver. Dude, that is extreme. And the jet stream is barely moving it. The jet stream is coming down. Well, we'll show you where it is here in just a minute. First, the radar map. Here is the U.S. radar situation. And where you have cold air and moist air meeting up, folks, that's where you have violent weather. I mean, you know, it's important to understand that, yeah, the moisture in tornadoes is caused by convection, you know, water heating up, evaporating, evaporative convection. That's what causes the water vapor component. But what really causes a severe thunderstorm is the cold air coming down. The Great Plains are Tornado Alley because of cold Canadian air coming down. It's the cold air that makes a storm violent. We have moist air all around the world, but no place gets tornadoes like the Great Plains, and it's because of air coming down from Alberta and, you know, Saskatchewan and central Ontario and stuff like that. That's what makes for the violent weather. Huge pressure gradients. Anyway, moving right along. Again, we hope you know how weather works. And of course, if you know how weather and aircraft work, you don't believe in chemtrails. So congratulations on that. Here's a really beautiful satellite map from windy.com. We'll also show temperature while we're on this map. You can see the sunrise there, as well as a great interpolated image using shortwave and other radar, other satellite data to show a great transition there without really a lot of crap on the nighttime side. And it's very cleaned up around the day-night terminator. So got to have that. Good times. We'll briefly show pressure. There's your pressure map. As you can see, we've got majorly strong lows here off the coast of Ireland, Scotland, as well as south of Greenland there off the coast of Newfoundland. And that is largely in control of the weather on the east part of the country, locking in this dry mass of air here. And here is temperature as it is very cold. Look at the temperatures in Vermont and New Hampshire there. Dangerously cold temperatures up here. How about negative 12 Fahrenheit? Montpellier, negative 11 Fahrenheit. That is legit cold, folks. And that doesn't happen every year, not even up there. So this really, really cold air just pushing its way down here. And let's take a look at nullschool.net. And then we'll show you some snow forecasts. Sound good? I hope it sounds good, because this is a weather and space weather dictatorship. Almost like a classroom. All right, so here are our surface winds. And you can see very windy conditions here in that North Atlantic. We talked about it yesterday. Very dangerous sailing conditions there. High waves, high winds, big time low pressure zones. Shout out to our viewers who are mariners. All right, so there's a great view of the U.S. Let's bring up the 250 hectopascal winds. And there you can see what the jet stream is up to. Cold air coming way down from Canada, making for some very, very cold temperatures there. Below freezing in South Carolina and all of North Carolina right now. And the winds here, that's 150 miles an hour there, I'll bet. 175 miles an hour. So an absolutely massive acceleration happening there as the jet stream moves over the Atlantic. And a big kink right here as it stagnates. So that's your jet stream. And look at this anticyclone here over San Francisco, right over San Francisco. We have an anticyclone there. Has a gateway to hell opened over San Francisco? Let us know in the comments what you think. All right. Yeah, that's a high pressure zone, an anticyclone. Now, we're going to show some forecasts here for snowfall. Yes, total accumulated snow depth forecast. Since we see so much moisture rolling in and so much cold air, let's do it. And we're only going to show snow here because positive snow depth change is what really matters, as regular rain isn't really that much of a big deal. So it's going to get pretty snowy here in the next 3 days. And here's where. So there's your GFS positive snow depth change forecast in inches. North Dakota is going to get a foot or so in certain sections. We're also going to show the thermodynamics, the 2-meter temperature forecast. And thanks for leaving comments, Mr. Bordages. Hopefully your winter is working out well. I know it's not technically winter yet. And of course, welcome to the darkest times. Yes, the darkest times. You're currently in the darkest 6 weeks of the year, folks. The darkest 6 weeks of the entire year have fallen upon us in the Northern Hemisphere. Or if you're in the Southern Hemisphere, the brightest 6 weeks of the year have fallen upon us. What dark times are these that passing ruffians may produce nonsense on YouTube and get paid a lot of money for it? Here's our 3-day or 72-hour GFS temperature forecast. And Pennsylvania is going to be a very cold. So that's what's up. That's where we're located. Let us know where you are, if you like, or keep lurking. And of course, we're going to show the jet stream forecast here just to show you what's responsible for pushing that cold air down. Now, we told you it's the jet stream, but people aren't convinced by stuff like that. In fact, many people aren't convinced in 2025, even if you do show them proof of a thing. So anyway, here is the jet stream forecast. The 250 millibar winds. So, but in about 3 days, we'll have a respite here in the Northeast, as it will get at least a little bit warmer and a little bit more seasonal in terms of the climate. So yeah, more CMEs on the way. Congratulations on realizing the channel exists. All of those things. And yeah, it's time to close this thing out. So we're going to cut back to the sun here for a minute. Take any comments. Once again, don't forget to tell your friends and foes that the channel exists, because frankly, the algorithm is completely broken. It doesn't matter what keywords you put in. None of it matters, folks. It's all nonsense. The algorithms are 100% manipulated. The NASDAQ is 100% overinflated. These companies are not pioneers in anything except misleading shareholders. The NASDAQ companies are all a joke. AI is a joke. And before they create a utopia on Earth, they'll have to create a functional smartphone app first. Wouldn't you agree? Anyway, here is the closest star once again. Thanks for gazing with us here at the Smash News Network, least busted name of news, at the most interesting star for humans in the universe. El Sol, the sun, whatever you'd like to call it. Tesla stock is about to crash. Mike, you're exactly right. Tesla stock is about to pop because it's part of the bubble. And I'm sure they can't write a functional smartphone app either. Anyway, it's time to close this thing out. See you next time here at the Smash News Network, least busted name of news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And until next time, may that solar wind be at your back. If there is a next time. Hopefully there'll be a next time. Bye.